basically UET net was gone, so it is back now. Are you hearing me?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Let's continue. Okay. I was talking about the experiments, and our main focus will be on the study of the machine, the different aspects of the machine, particularly related to the selection of the machines. And obviously, some of the machines are missing here. Those machines which are being utilized at industrial level, I will give you a brief introduction to those machines as well. However, our main focus will be on these machines which are enlisted here. The secondary purpose is to measure the performance of the machine. So here comes one question. Here comes one question before going into the detail. What do you think the basic job of an engineer? Just in one word, basic job of an engineer.
Jugaad.
Yes, roll number 38. 38.
Be practical.
Be practical. Dear anyone else, please? Yes, roll number 96.
Solve the problem and find the create new solution for problems.
Create new solution. So you can say that innovation. Innovation is the job of an engineer. That is very right. Innovation. That is really good. Okay. What else? What else? This is innovation is in those cases where you don't find the solution from the earlier provided, or don't find the solutions from the routine practices. Then there comes the innovation. But what is the routine job? Innovation is not the routine job, it's a rare job. It is in a rare case when you don't find the solution from the routine standard practices. Yes, 42.
Sir, to measure performance.
Measure performance. Then what? This is it. Measure performance.
Yes, sir, and sir, that's it.
Okay, anyone else? Anyone else? Okay, I'm telling you, there are three primary or basic jobs of an engineer, and there is one word to describe each job. So the third one is the innovation or innovate. Being an engineer, you need to innovate. But in some cases, in rare cases, you are going to do it. And for that, you need a thorough understanding of your subject. A deep understanding is required for innovation. Deep understanding. But the innovation is not the routine job. What is the routine job? There are two other jobs which are it's a job of every engineer, whether you are electrical, whoever you are. Yes, roll number 11.
Sir, to keep check on the process.
Then what? What will you do after checking the process? Row number 11. What will you do after checking the process?
So we will find out if this is correct or incorrect.
Then what? If it is incorrect, what you do?
Then we have to find a way to make it correct.
Okay, row number 9, please. Row number 9.
Sir, in order to drive a process for a smooth running of the plant.
Just one word. One word, please. Anyone else? Dear, you are becoming engineer and you are not familiar what is your primary responsibility. All other things comes in those primary responsibility. Yes, row number 5. Row number 5.
Improvement.
Improvement. In what sense? Improvement
Like
in what?
some plant job we have to remove that, so we'll improve the plant.
Okay, it is related to the second job, improvement, but improvement is not the right word for it. The right word for it is optimization. Optimize. Optimize is the primary or routine job. Whenever you are going to get a job, you are going to, your basic responsibility will be to optimize the process, optimize everything, optimize the economics, optimize the first stage of the process, optimize the second stage of the process, optimize the overall process. So the optimization is your primary responsibility. What else? We got to innovation, optimization. What is the third one? What is the third one? Yes, row number 9. The third one. The third one.
Sir, improvisation.
Sorry, repeat. What? The third one, please. Please think about it. Being an engineer, when you are doing a job at industrial level, what you are going to do, what you are supposed to do. Think about it. The basic thing is that you should think. 96. Yes.
Yes, sir. For engineering, we have to create the best product in less power and
All right, this is someone related to the third objective, but not the accurate definition. But it's all right. I know you are in the second year, the third semester, so you need to learn a lot of things, and you will learn with the passage of time. So the third responsibility is to design, right? So when when the designing comes, when does the designing come? That is when you have a lot of experience. You cannot go to the designing stage after passing out your engineering degree, engineering program. When you are going to enter the industry, your first job is the optimization. You familiar with the process and optimize the process and everything which is related to optimization that you have to do. And there comes a lot of things. For example, the optimum to measure the performance and then suggest the improvements, that is optimization. To calculate the economics of the process, then suggest the changes, that will reduce the cost and increase the productivity and increase the revenue. That is, then there comes the management optimization as well. If you are working an engineer and there are number of workers, laborers or supervisors who are working under your supervision, you need to optimize the work of them as well. Right? So you need to get the most of it, most of them. Right? So this is the optimization. That is your first primary responsibility. And in order to optimize the process, you need to first measure the performance. You are not going to able to optimize the process. You are not going to able to find the drawback at different stages of the processing unit or the chemical processing unit, right? So first you need to measure the performance. Once you measure the performance with the standard values, what are the expected values of the performance? You will never get 100% performance. What to do to increase the performance up to a level which is acceptable. So there are some guidelines, there are some values provided in the literature and which define the benchmark for the performance of each machine. For example, there is a crushing unit. The bench is 75% efficiency. What you are measuring is 67%. So 7%. You need to increase it to 75%. Then you need to find a drawback where what in the crushing process which are decreasing the efficiency of the crusher. The benchmark is 75%. You are getting 67%. What is the drawback? Find the drawback. Remove it. That is optimal. And for this, you need to learn how to measure the performance. You need to learn how to change the process. And for this purpose, you need to understand the relations of design and operating parameters, right? Or feed characteristics. You need to understand the different design and operating parameters of the machine with machine performance. So, for example, there is a crusher size. By increasing the size, will the performance increase or decrease? You need to understand that. And then you are going to test those parameters to increase the performance up to the benchmark. That is your primary job, optimization. And this is the same for every aspect, whether it is a management, whether it is a technical. So you need to optimize all those things. And for the optimization of those things, you need to study all the relevant parameters which are in the performance. So here, what we are going to do, how their design and operating parameters going to affect their performance and how we can change some parameters, we can change some parameters. We're going to study all these things, right? Then there comes the design, the second job. Design means you are going to design a whole process. You are going to establish a new industry unless you have an experience of 5 to 10 years. At least you require 5 years experience at industrial level to understand all the to design a new unit. There are many things you will be able to cover from your studying the book. You need to do some practice. and you want to design a plant and condition. But the fight is you can get a country for the production of concrete. Then this is the limitation. How you are going to handle them? So these are the minor details. Sometimes you don't find the thing within the country. You need to import that. And for import, there are many other things which comes into consideration like custom, etc., and many other things, right? So there are some limitations. You need to understand all those limitations. Then you will be able to design carefully the processes, the whole process, the whole plant. So you need to require at least 5 to 10 years experience to come to the designing stage, right? And you know that the salary of the salary of a field engineer, right? Design engineer will get more salary as compared to field engineer because there is an experience behind it. So innovation, I have already told you sometimes if you are working in the field, there comes a problem and you will not be able to find the solution from the routine practices or routine solutions. So you need to innovate, you need to think to find solution for that particular problem. So then you should be able to innovate. And it's possible if you deeply understand the process. If you deeply understand which are causing the problem, and then you will be able to innovate the thing. Our course educational objective, that is the main objective, educational objective of this course is get familiar with the practical aspects of various particle technologies including crushing, grinding and sizing. These are our focuses, crushing, grinding and sizing. We will focus on these three processes only. Course learning outcomes, there will be three learning outcomes. The first one is to perform experiments related to size reduction, size separation equipment by following experimental and safety guidelines. So I will measure the third psychomotor level, and there will be two IVAs and lab continuous assessment during your lab, right? CLO. Total 100 points mean 100 percentage. So the weightage for the first CLO will be 15. 15 for first viva, 15 for second viva, and 20 for continuous assessment during your lab. So there will be some psychomotor chart. I will give it to the lab staff, and the lab staff during the performance they will measure your different aspects. I will provide you that chart to you so that you should be familiar what you are going to be form. So it will be related this first year coming out. You should be able to interpret and analyze the experimental observations and draw valid conclusions. That is the ability you should gain at the end of this course. And then this comes in effective domain. That is the attitude. It is related to your ability or attitude, and it will be measured from your report. There will be a section of discussions in every experimental report, in the report of every experiment. A section of discussions. The second CLO related to the discussion section of your experiment, 20 points. There will be a 20% weightage. Every student will report 4 experiments, and the discussion of every experiment will contain 5 points. 4 experiments, total 20 points. And it is related to PLO4, investigation. You need to investigate the experimental data, analyze it, and deduct some new information, relate it to the standards. So you need to be able to do it, to develop such kind of property. The third one is report the experimental observations and results without plagiarism. The main focus is without plagiarism. 20% is allowed. I will take your reports both in soft form and hard form. And when you submit the soft form, I will measure the similarity index from the website Turnitin. I have an account on Turnitin, and I think every faculty member have an account. So I will measure the similarity report of your lab report, and if the plagiarism is less than 20%, then it is okay. There will be no deduction of your marks. But if the similarity is greater than 20, then for every 1% increase above 20%, there will be a deduction of 1 mark, right? And above 50%, you will get 0 marks, right? Because the total are 30 marks. It is also related to effective domain. Sorry, this one is the cognitive domain, this one is the effective domain, right? So you need to learn how to write a technical report. Obviously, the format of the report and the style of the report is also important here. I will share the rubrics of the report as well. You will able to understand what you are supposed to do, what you are supposed to write in your report. And also I will share the rubrics of YY as well. Just at the end of the presentation, I will share those things. These are the target PLOs. The first one is the engineering knowledge related to CLO1. The second one is the investigation related to CLO2, and then communication. That is the ability to communicate effectively orally as well as writing. Right? Just to give you an information what you are supposed to develop as your skill, as your ability. Right? So by the end of this course, you should be able to apply knowledge of mathematics, science and engineering fundamentals related to particle technology to find the solution of an engineering problem in particle technology. Right? Similarly, the investigation and communication is all related to reporting and presentation. Right? It is all related to report writing and presentation. And obviously, at when you are working at industrial, it is related to interpersonal and social skills as well. So you need to develop those skills as well. Here, the engineering is all about knowledge and skills, and then application. Recommended material. Lab manual. Obviously, I will provide lab manual, but it will only contain the format related to the lab experiment. I will not provide you the theory related to the each experiment. I will not provide the theory, just only the main things which you are supposed to do in writing of each in writing of report of each experiment, right? And the reference materials. The first book, Mineral Processing Technology by B.A. Wills, 8th edition. It is available on the website Library Genesis. You can download it from there. All these 3 books are available on Library Genesis. But I recommend it. First, you should read the relevant portion from this book. Only relevant portion. If you want to read the whole book, it is up to you. But I think it is more appropriate if you read the relevant section only first, and then read the relevant sections in these 2 books and understand those things. Here the thing is, you need to understand those things and reproduce in your own words. You don't need to memorize those things. You need to understand those things. Right? Obviously, there will be a few things you need to memorize, like type of definitions or some values. You need to memorize those, but the primary focus is on the understanding of the things. Right? So 90% is related to the understanding, and 10% is related to memorization, or you can say the cramming. So I recommend you first read the relevant material from the first book, then from the second book, then from the third book. Right? B.A. Wills books is the textbook, and obviously this one. Some of the things you will find here, some of the things you will find in the second book, which are not present in the first book, and the third one is in relatively in detail. right? So just read the relevant sections and try to understand things. Details master plan. This is my plan for your lab. Today is the first week, and we are discussing the introduction of course, and we will finish it today. Then in the next week, you will perform two experiments. The first one is on the jaw pressure, and the second one is on the roll pressure. There comes the third week. You will perform another two experiments. One is on hammer mill, and the second one is on disc mill. So in the fourth week, there is going to be viva and submission of lab report of the four experiments, right? And then after that, in the fifth week, we will perform two grinding experiments, and in the sixth week, we will perform sizing experiments. Then in the seventh week, there will be a viva and submission of lab report, and your lab is done. I planned it to finish it before the midterm, right? Because you know the COVID situation, and the COVID situation, I'm not sure we will be able to do a lab after midterm. I'm not sure about it. As far as the instructions from the higher up is that there will be only 2 months available for your session, and after that you will go online. But you know, this is the physical lab. You need to perform experiments in the lab, so that's why I have planned it to finish it before the midterm. Yes, 58, please go ahead. Here's the question.
Sir, what if the entire semester is online? What are you planning to do then?
Obviously, I will plan subsequently. If the entire semester is going to be online, then we will have some online lectures related to the instructions and theoretical background, understanding of the different parameters and theoretical backgrounds of the machine. Then we will perform experiments in the time slot provided by the hierarchy. I remember last time 3 weeks were provided, 3 weeks for the lab work, right? So obviously there will be some solution for this problem, but I am hoping that we will be able to do all these things on campus. I'm hoping that the government may allow us to start proper session on campus after 15, after tomorrow. Let's see what,
Inshallah.
inshallah. Okay. Then there comes components, Viva continuous assessment 15 points, and experimental lab report 50 points. 34 the report writing and 24 discussion section. Right. Of course, you're always welcome if you want to discuss anything which I didn't cover in your lecture, or which you are finding difficulty in. If you are reading the book and if you are finding difficulty in any thing there, you can me. You can come to my office. My office is available in mining engineering department, ground floor, and room number is 115. Room number is 115 on ground floor. It is just beside the lab. Actually, it is connected with the lab. So there are two doors of my office. One is connected with the lab. So you can come to my office anytime during the official hours, obviously between 8 to 4. And other than that, you can also contact me on my WhatsApp number. Please don't call, just text me whatever the problem is. I will reply you sooner or later. Sometimes I'm busy, so I see the message and reply it later. So you will get the reply after all, but be patient if you are texting me on WhatsApp. You are allowed to text me at any time, but when I got that time, I will reply at my own schedule. Okay. For the introduction, one more thing. How we are going to do? They are total 39 students. CR2 is the CR.
Yes, sir.
Yes. There are 39 students in section A and 39 in section B. Am I right?
Yes, sir.
All right. So I'm going to divide. These each section into three major groups, right? Three major groups, and they will be there will be
13 students in the group.
13 students in the group. But I want to further divide into smaller groups. 3 students in a smaller group. 3 students in a group. So 12 or 15 in one, and the other are in other groups. So maybe it's 15, then there will be 12 and 12 students. Two groups will consist of 12 and 12 students, and one group will consist of 15 students. And each group will be further divided into smaller groups. Each small group will contain 3 students, right? So what I'm going to do, there are total 9 experiments. In each small group containing 3 members, each member is supposed to write a lab report of 3 experiments. One from crushing section, one from grinding section, and one from sizing section. But when they are going to submit the report in hard form they will submit the report cumulatively, right? They will submit a single report, but in soft form they will submit individual experiments, right? So you are supposed, every student is supposed to write a report on 3 experiments, right? So it will make the things easier for you, and it will make the things easier for me as well. But the main thing is learning. When you submit the first report, then I will give the remarks, my remarks on that report, and you are going to rectify your next report, right? So this is how it's gonna work. One more thing, I have talked to your department, since we are going to do it before the midterm, so your lab will be double paced. It means that we are going to spend 6 hours per week on particle technology lab. And I have already informed to your department that this is my plan and this is what I'm gonna do. So section A, you are going to perform lab on Monday. You have a slot from 3 to 4. So there will be 3 groups of section A, and first group of section A will perform experiments on Monday 3 to 4. Actually it is 2 to 4. No, 3 to 4. It is 3 to 4. One lecture is free in the timetable. And there comes the Tuesday from 8 to 11. The remaining 2 groups will perform experiments on Tuesday. Group number second containing 12 or 12 students, and group number 3 containing 12 students. Right? And section B, you will perform, the first 2 groups will perform experiments in the lab on Tuesday from 1 to 4 p.m. From 1 to 4 p.m. Then there is a slot of 1 hour available on Thursday from 3 to 4. The group number 3 in section B will perform experiment on Thursday from 3 to 4. And I want that please make the groups in such a way that one of these 3 major groups should consist of all host slides. It should be consisted of all host slides, right? For both sections. Are you getting it, Sia? Are you getting it?
Yes, sir.
Okay. The one group,
Yes, sir.
it means around 12 students should be host slides, because on Monday and Thursday we have only 1 hour. So it may go for half an hour more. That's why I need all host slides in one group. one of these three groups, right? And obviously they will be subdivided into four groups containing each group containing three members. Then there is a slot of 2 hours on Friday from 2 to 4. That slot is available for both sections, section A and section B. Both are free on Friday from 2 to 4 p.m. There will be instructions and discussions related to the different aspects of the machines. So combined, this will be a combined class. Both A and B sections will attend. Either it is an online class or it is on campus class. I prefer it, inshallah it will be on campus class. So I will take this class maybe in your department where the capacity is more. I need to visit first. Obviously I will visit tomorrow or maybe today to find the facilities. CR, you can tell me, is there a room where both sections can fit in your department?
Yes, seminar hall is available, and yeah,
Seminar hall is too big. You are talking about the seminar hall beside your chemical engineering department building.
yes, sir.
Yes.
Is there any other room where both sections can fit? Is there?
Sir, students can be fitted. Then there might be a problem of SOPs.
All right, all right. I will see what I can find about it. So I will inform you later. So I think I have shared all the information. Is there any question? Okay, no question. I would like to show you the rubrics as well. I am going to share your course file. What I have discussed today, I will provide you in PDF as well. And obviously, if you need a presentation, these PPTs, I will provide the PPTs as well. And please download the books as soon as possible and start reading. Reading is important. Okay, I am sharing an Excel file. Can you see it?
Yes, sir.
Rubrics. There will be given there. Weightage may vary. I need to modify it a little bit, but here the first component consists of introduction, construction, and working of the machine, applications and limitation, and advantages and disadvantages. I will ask questions related to these things of every machine which we are going to study in your lab, and these are related to your Viva. The different levels. This is the maximum level where if some student is demonstrating deep knowledge about the several objectives of the machine, all major and minor components and their individual functions as well as functions in combination, all major and minor applications and limitations in relevant as well as in other fields, all major and minor advantages and disadvantages with clear understanding of the situations in which the machine suits perfectly for certain operations. If some students knows all and provide all the information during the Viva related to all those machines, then that student will get the maximum mark, 4 out of 4. And then there comes the second types of the machine. The exemplary, the maximum marks point is demonstration of deep knowledge about the description of types of machines and all the major and minor differences between them, all major and minor factors influencing the selection for the types along the models or expression. Models of expressions means equations which aid the selection. Having clear understanding of all specifics of the circumstances under which each type is suitable for operation at industrial scale, and all major and minor merits and demerits. This is the second section of the Viva for maximum marks. The third one, performance measurement, design and operating parameters affecting performance. Obviously, this section will contain more weightage because it is related to the optimization, your first job at the industry. So demonstration of detailed procedure with clear knowledge of minor details about the performance indicators and their measurement at both laboratory and industrial level. Student with excellent exemplary knowledge should have known all these details, should be able to reproduce those details. Deep understanding of the effects of various major and minor design and operating parameters of the machine on its performance indicators with the description of empirical and mathematical model. You need to find the equations as well. Equations are provided in those books as well. There is another book if you need to find more equations or mathematical model. There is a book, mineral processing. It's okay. I will provide that book. It is basically modeling and simulation of mineral processing systems. Okay? It is modeling and simulation of mineral processing systems, and that book contains all the equations related to your machines which we are studying here. Last one, sieve analysis and lab experiment knowledge. Of deep understanding of objectives, procedure of sieve analysis, selection of sieves and their selection criteria, their importance and application of sieve analysis results at industrial level, the deduction of several kinds of information from sieve analysis results and their utilization at design and operating phases of processing plant. Deep understanding of the experiment and its objectives, procedure, results and limitations, discussions on the results, deduction of information about the performance of the machine and its comparison with the literature values. So these are the maximum marks for such kind of knowledge during the Viva. I will ask questions, and normally it takes 10 to 15 minutes on one students to know its basis. For me to know a student how much he or she does know, it takes normally 10 to 15 minutes. So be ready for that. Your Viva for individual students will take 10 to 15 minutes. Right? Okay, these are the rubrics for the Viva. The next one, rubrics for the lab reports. Okay. This is the Word file. Here you are supposed to write. This is the first section, abstract or summary of the experiment and related theory, experimental procedure, calculations, results, tables and graphs, and then discussions. Obviously, discussion. Key points of 100, right? So here this percentage may vary, right? Then spelling, grammar, sentence structure, appearance, format, and here I would like to show the assessment of previous students so that you can have an idea how I am going to check your lab reports. Okay, it will be Can you see this Excel file? Can you see?
Yes, sir.
You can
Yes,
see
sir.
at the top. See at the top to write importance of the experiment, objective. Obviously, in brief, it is the summary. Just 5-6 lines will contain the whole summary, and these 5-6 lines should include the importance, objective, methodology, and the related theory. In related theory, the subheadings will be introduction, types. You can see in parentheses the marks allocated to each subheading, types, construction and working, operating parameters, design and operating parameters of some common industrial model. You can find it from the Google as well. If you write the specifications of job crashes, you will find the tables. You need to produce those tables or include those tables in your lab. Theory section. Then there comes the procedure. In procedure, machine study, problem. Observations and calculations. Laboratory observations will contain 2 marks. Then calculation tables will contain 5 marks. There will be number of graphs involved in each experiment, and the first graph will hold 5 marks. If you calculate the parameters, you will get the maximum mark. And the graph number 2, 3, 4, and in the end, calculations of reduction ratio, energy consumption, and capacity. Right? It will contain total 5. Discussions discussions on reduction ratio, energy consumption, capacity, discussions on graphs, discussion of experiments, and conclusions. This is the discussion section. Spelling mistakes, sentence structure style, it is simple or it is complex or it is whatever it is, I will check it. Last one, appearance and format. Title page, table of contents, header and footer, list of figures, list of main text, justified, organization, table number, and reference in text. And here you can see the similarity index. So green is for you can say past, means no deduction. Yellow is for they say deduction of some marks, and red means no marks. Red is for those where I find a similarity index above 50%, right? So between 20 to 50%, they will be a yellow, and below 20% or 20% inside. So this is how I'm going to check your lab report. Okay, the next one. Roll number 54, yes.
सर ये लैब रिपोर्ट्स के स्टैंडर्ड बता रहे थे ना आप?
हाँ जी, मैं लैब रिपोर्ट का बता रहा था कि मैं किन किन चीज़ों को चेक करूंगा और हर एक के मार्क्स भी गिवन है. अगर किसी ने कोई चीज़ मिस की है तो मार्क्स खत्म, 0.
ओके सर.
ठीक है. ओके जी बच्चे. एनी अदर क्वेश्चन? $54. Do you have another question?
Excuse me, sir.
नो सर.
Yes.
सर सर ये फाइल्स कब शेयर करेंगे?
I will share it today, inshallah.
Okay, sir. Thank you.
I will share to CR. I hope. Should I share it on MS Word or CR?
Sir, MS Teams पे अपलोड कर दें so that it is accessible to everyone.
All right, I will upload to on MS Teams. All right, I will do it today.
नहीं सर जी,
Yes.
यार MS Teams पे काफी स्टूडेंट्स को शो नहीं होती, वो कहते हैं, तो इसलिए WhatsApp पे बेहतर है.
Okay, I will do it on both case in both cases.
Yes, sir.
So I will share with CR as well. I will share on MS Team as well. So this is about the introduction. We still have about 50 minutes. So we are going to discuss our third section, third section of the lecture, which is related to the uh, experiment number 1, or the introduction to ChE. Let's have a break of 5 minutes, and then we will start experiment number 1. We will start discussions and the instructions related to the experiment number 1. Let's have a 5-minute break.
Excuse me, sir.
Okay, dear. Let's continue. 5 minutes are up, and now we are going to discuss the first experiment. Is PowerPoint visible to everyone?
Yes, sir.
All right. Let's continue. Our first experiment is on jaw pressure. Here are the presentation scheme. The first one we are going to discuss the objectives, then there will be some information on specifications of laboratory jaw pressure, and there comes the observations and calculations, and then related theory. In related theory, we are going to discuss the introduction of the machine, then types, construction and working, performance indicators, parameters affecting performance, and applications and limitations. Obviously, in the end, I will show some specifications of common industrial models. So let's start from the objectives. The objective of this experiment. The main objective of the experiment is to study the various parts of the jaw crusher, with special emphasis on their functions. It means that you should have an understanding of functions of all the parts of the machine, so that if you need to innovate at some point of your career, you should be able to have an deep understanding of the previous work of previous machines or the machine like jaw crusher. And if you need to modify its design, then you should have a knowledge of the function of each part as well. Because if you are going to innovate, if you are going to design, or if you are going to modify its design, then you should know what is there at the initial stage and what was the problem and how you are gonna solve it. Right? So that's why we are going to study each and every part of the jaw question. Then after that, after studying the machine, we will perform experiments on a given sample. We will use some rock samples, large pieces or lumps, and then we will put those pieces into a running jaw crusher. Crusher will break those lumps into smaller fragments. We will collect the product, and we will measure the size of the product through sieve analysis. Obviously, there will be variations in size of the product, and we will measure those variations, and we will find out the average size, right? And we are going to we are going to calculate the deduction ratio and capacity and energy consumption. Deduction ratio will be calculated by measuring feed size and product size, and the capacity and energy consumption will be calculated by using mathematical equations or expressions. So you are going to do it by yourself. I will just guide you, and I will explain how to calculate the deduction ratio. And these three are the performance indicators of the machine. Whenever you are going to uh, measure the performance of the machine, you should know the objective of the machine, right? And based on that objective, you will define the performance indicator. Let me give you one example. What is the function of a fan, ceiling fan? Can anybody tell me? What do we want from a ceiling fan? Fan, running fan. What do we want from a fan? Please raise your hand. What is the purpose of the fan? Objective of the fan. Dear, are you there? Yes, 58.
Sir, cooling the room.
Is cooling the basic function of the fan? Are you sure about it?
No, sir, I'm not sure.
Cooling is the basic function of an air conditioner. Cooling is not the function of the fan.
Sir, basically, I'm not comparing AC to a fan. I'm just
No. I'm
describing.
talking about the fan. I'm just telling you, cooling is not the primary function or primary objective of a fan. Cooling is the primary objective of an air conditioner. Roll number 40, roll number 9. 9. Yes, 9 first. You raise hand first.
Sir, in order to circulate the air in the room.
Okay, circulation of room. Okay, that's very right. And roll number 11, you would like to add something?
No, sir, I want to say the same.
Okay. If you want to measure the performance of a fan, how are you gonna measure it? Just tell me. Think about it. There's a fan installed in your room. It is running. You want to see whether it is operating efficiently or not. You need to measure something. What you are gonna measure? Row number 11. Yes.
Sir, first of all, we will measure the energy consumption of the fan.
First of all, okay, energy consumption is one thing. It is related to the cost. But what is the primary objective? Primary thing you need to measure?
The speed of the wind in the room.
Speed of the wind. If the higher speed, does the higher speed ensure the higher performance? If you increase the power, the speed will be higher.
Direction of the circulation of wings also includes the performance.
Sorry, dear. Anyone else? 96. 96.
Yes, sir. By measure the air come from fan.
By measure the air come from fan. And how you are going to measure it? What thing
By
you will
feeling.
measure? By feeling.
Feeling.
Dear, feeling is different for different purpose. If there is a weak person, he will feel more. There is a strong person, he will feel less. Right? So
Yes.
feeling is not a standard measuring tool.
If there is a paper in the room, it will move.
Papers, what will be the size of the paper? And what type of paper will you use? A light one or a harder one? There comes different questions related to paper. So this is not the standard thing, standard procedure. Yes, 54. 54.
So first we will calculate the working capacity by calculating the RPM. Then we will calculate the energy consumption. And
Dear, the primary objective of a fan is to circulate the air within the room. Is it right? Primary function.
सर वो घूमेगा तो एयर सर्कुलेट होगी ना, तो आरपीएम कैलकुलेट कर सकते हैं।
बच्चे को ज़्यादा भी हम उसको घुमा सकते हैं अगर हम पावर ज़्यादा दे दें, विंग उसके बड़े कर दें, ज़्यादा घुमा देगा, ठीक है। तो क्या इसका मतलब ये है कि वो एफिशिएंट हो गया, ठीक है। ट्राई टू थिंक अबाउट इट। Here you need to measure the circulation of air. You need to measure the circulation of air in relation to size of the fan. But how you are going to measure the circulation of air? The amount of circulation of air. Amount of circulation of air. How you are gonna do it? Yes, 06.
Sir, by measuring the kinetic energy of particles.
Of what particles?
Air particles.
Air particles. To some extent, you are right. Basically, when the fan circulates, when the fan rotates, it circulates the air, and there is a variation between the kinetic energy of different sections of the room. The section which is under the fan will have more kinetic energy, more pressure as well, right? It will exert pressure on the air molecules, so it will push the air molecules below its wings, right? Its wings will push the air molecules in downward direction. So we need to measure the kinetic energy, but here kinetic energy is equal to half mv square. Mass of the air, let's say it's constant within the room, then we need to measure the velocity of the air. The velocity of the air is related to the circulation of the air within the room. Am I right?
Yes, sir.
So to measure the performance of a fan, we need to measure the velocity of the air below the fan, right, at different points. Obviously, the point may be different. For example, the fan is hanged on the ceiling and there is a distance between the floor and the fan wings is about 8 feet. You need to measure the velocity of the air at 6 feet above ground, 4 feet above ground, 2 feet above ground, and at the surface of the ground. So you will measure the velocity of the fan at different positions, and then you will compare it to the standards, right? So one more thing, you need to measure the pressure as well. So if the wings are damaged, it will not produce more velocity. If the wings are damaged, it will not produce the more velocity. If the power is low, it will not produce the more velocity, right? And obviously, being a human being, we are human beings, we need a certain range of velocity and pressure. If the pressure is more and we are sitting below the fan, we will not be able to bear that pressure, right? If the pressure is more, it will damage our muscles if the pressure is more. So we require a certain pressure, and obviously if the velocity is very high, like in thunderstorm, we are not gonna bear it. It will be dangerous for our body. So we require a certain. So we need to measure those velocities in order to measure the performance of the fan. And obviously, these velocity values, pressure values are related to the different parameters like its motor capacity, power obviously, and its wing size, wing design, shape as well. The wing shape is very important, and some other things as well. Right? So you are going to measure the velocity, and if the velocity is within the range of human bearing, then it is fine. And at the same time, if the same velocity is provided by a different fan with less energy consumption, then we can say that the other fan will be more efficient. So velocity is not the only parameter. We need more than one parameter to measure the performance of a fan. If there are two fans having same design, same wings, but one fan is consuming less energy, providing the same air velocity, then the fan which is consuming less energy will be more efficient. So we need simultaneously, we need to consider the size of the fan, the velocity it is providing, the pressure it is creating, and the energy it is consuming. All these four things in a cumulative form will define the efficiency of a fan. Same is the case for every machine. The first thing, in case of fan, the first two things, air velocity and air pressure created by fan. These two are the primary job of a fan. Similarly, for a crushing machine, the primary job is to crush the particles into smaller size. So we are going to measure that this machine, how many times this machine is going to reduce the particle size, and that is measured by reduction ratio. That is measured by reduction ratio. So reduction ratio is the performance indicator of a crushing machine. But the problem is we can achieve higher reduction ratios by using large machines, right? We can achieve higher reduction ratios by using large machines, and large machines will consume more energy. So we are at the same point. We need a machine which can provide higher reduction ratio, consuming less energy. And also, if we are achieving higher reduction ratio, there is a machine which is reducing particles. If the particles are present within the machine, inside the machine for larger time, it will be broken into further smaller particles. But it will take more time. And if the particles are taking more time, the capacity will be reduced. The machine is not treating the material, more material in unit time. Let's say 1 hour is the unit time. So if the particles are taking more time within the machine to produce higher reduction ratio, then the particles are taking more time, then the capacity will be reduced. The material treated by the machine in 1 hour will be reduced. It means that all these three performance indicators are related to each other as well, right? So we need to measure all these three values, and then the picture will be clear about the performance of the machine. A single component cannot define the whole performance of the machine. We need all these three values simultaneously at the same conditions, under the same conditions, and to measure the performance of the crushing machine. That's why we are gonna do it. We are going to measure the reduction ratio, capacity, and energy consumption. These are the objectives of our crushing and grinding experiments. Then there comes the specifications of laboratory job pressures. This is the information provided here. You need these informations to calculate the capacity and energy consumption. That's why it is provided here, right? The motor which is attached here in laboratory job pressure, its power is given 5 HP. Then motor RPM is given 440 revolutions per minute. Pressure RPM, pressure is here. There are plates present here, so its RPM is different from the motor. This is because we are using here a pulley. Two pulleys are present here. You know the ratio. If this pulley is small, this one is large, then the thing which is attached with this pulley will have less RPM as compared to this one, right? So where the pulley small, there will be more RPM. Where the pulley is large, there will be less RPM. This is how we convert higher RPM into lower RPM into higher RPM. The RPM for the motor is usually fixed. We need to change the RPM of the crusher. Then accordingly, we choose the diameter of that pulley. Increasing the diameter will reduce the RPM linearly, right? More you increase the diameter, there will be less RPM for the movable jaw, the fixed jaw. I will explain. I think you may not understand these things right now, but I will explain later in a picture of the machine. Observations and calculations. Will measure the feed size, product size. I will explain how you are gonna calculate all these things in the next lecture. Once you perform one experiment, you will get the values here. You will get all length, width, and height of the feed size in case of jaw pressure. But here for product size, you will have only two things: retaining the purchase size of the sieve, this column, and the measured masses in grams, this column. You will have only these two columns from your experiment. You will get the values from the experiment for these two columns only. All the remaining columns, and the values in the remaining columns like this one, this one. These values will be produced by calculations, and I will explain in the later lectures how you are gonna do it. Calculations, you are supposed to calculate the deduction ratio. It's 80% passing feed size, 80% passing product size. What is it? I will explain it later. And you are supposed to calculate capacity and energy consumption based on some mathematical equations, and those mathematical equations are given in the book Mineral Processing Design and Operation by Gupta and Yon. You are required to download that book and read the book and take the equations and put the values on those equations, and then calculate the capacity and energy consumption for the laboratory jaw pressure graph. You are supposed to draw four graphs. First one is between cumulative passing and retaining mass percentage against the purchase size, geometric mean size, and then you are supposed to find the values of D10, D25, D50, D75 from that graph. First graph, plotting the graph will contain three percentage of the lab report of that experiment, and then finding the values of these parameters will hold 2% of that experiment, right? So you need to do both things simultaneously. Then there comes the second graph, which is called low normal plot, in which the purchase size is logged. Log means you will take the log of the purchase size and plot along the x-axis, and on the y-axis cumulative mass percentage will be a normal. Then there comes the Gordon-Schumann distribution, where both axes are logged. You will take the log of both x-axis and y-axis and plot it on the graph. Here comes the Rosen-Ramler distribution. It's a different one, and there are some parameters associated. Two parameters associated with Gordon-Schumann distribution and two parameters for Rosen-Ramler distribution. Once you plot these graphs, you are supposed to find out the values of those constants associated with these two graphs, and you will report those constants and discuss those constants in your lab reports. All the information about plotting these graphs is given in the book Mineral Processing Design and Operation Gupta and Yon, and the topic is 2.2 particle size distribution. Read that topic and you will be able to understand. Also, there is another book in that book, some information related to those graphs is also provided. So I have provided the name of the second book as well in your course file, and I will share the course file after the end of this lecture, hopefully. Let's discuss the theoretical portion. Questions so far? Any questions so far? Okay. I think we should 8 minutes are left. Let's have an attendance and we'll start the theoretical portion on Friday. All right.
Okay, sir.
Okay. Please mark your attendance in the chat box. Write your name and roll number simultaneously. Mark your attendance here when you are done.